Okay, so chapter 4 has a little intro on statistics, the topic of chapter 4. So whereas probability theory is primarily focused on the relations among mathematical objects, so for instance, how does the expectation relate to the variance? How are the central moments related to the expectation? How are the central moments related to the random variable itself, constants that scale that random variable, etc. Statistics is concerned with making sense of the outcomes of observation. However, we frequently use statistical methods to estimate probabilistic models. For instance, we will learn how to estimate the standard deviation of a random process we have some reason to expect has a Gaussian probability distribution. So even though when we measure things, we don't always know if that underlying process is Gaussian or a binomial probability mass function or something else, we will often say, based on some argument, some physical argument typically, this process should have this sort of distribution, and so we'll estimate this parameter that's associated with this probability density function, or this probability mass function. Or we've done enough measurements that we feel confident that this is a Gaussian noise process, and so therefore we'll treat it as such. Statistics has applications in nearly every applied science and engineering discipline. Anytime measurements are made, statistical analysis is how one makes sense of the results. For instance, determining a reasonable level of confidence in a measured parameter requires statistics. A particularly hot topic nowadays is machine learning, which seems to be a field with applications that continue to expand. They just keep going. Machine learning is everything now. This field is fundamentally built on statistics, so it's good to have that down first before you start wading into machine learning. A good introduction to statistics appears at the end of the text by Ash, and a more involved introduction is given by Jaynes. The treatment by Kreisig is rather incomplete, as will be our own, but ours is going to be very practical and applied to things that we are going to see. Taking measurements, how do we put error bars on the data that mean something? What do those error bars mean? That type of thing. Okay.